probability where you need to be careful with the fractions that you put on the branches of a probability tree. So in this setup, I'm talking about a bag that has blue balls and red balls. Let's say it's got 3 blue and 4 red. What you have to do when you're told that 2 balls come out of the bag is just take the ordinary English meaning of taking 2 balls out of a bag. Let's say these were not balls but chocolates, and I said you could have 2 chocolates. Nobody would take 1 chocolate and then put it back in before they take their second. They just take 2. And that works its way into the probability tree in the following way. On the first stage, it's all pretty straightforward. It's 3 out of 7 and 4 out of 7. That just comes from counting the blue and the red balls. But crucially, on the second stage, there's now only 6 balls in the bag. So these will not be out of 6, they'll be out of 7. Sorry, these will not be out of 7, they'll be out of 6. And you need to be very careful. If there were 4 red and 1 got pulled out, there's now only 3 red. If that's 3 out of 6, this has to be 3 out of 6 as well, which makes sense. I mean that because they need to add up to, those 2 fractions need to add up to the number 1. And that makes sense because there were 3 blues in the bag, a red got pulled out, so there's still 3 left. If a blue gets pulled out, there's no longer 3, there's now 2. And that means a red is pulled out, so that means there's still 4, and they add up. Those 2 fractions add up to 1 as they should. So that's what comment 857 says. It reminds you that this procedure of 7 to 6 needs to be undertaken. If you get comment 857 a lot, practice probability tree questions a lot.